This is the Java series. In the previous sessions, we have discussed about the OOPS pillars, that is encapsulation and inheritance. Now, we will discuss about the third pillar, polymorphism. What is polymorphism? It is used to perform a single action in different ways. Okay, and this is derived from two Greek words, poly and morphs. Poly means many, morphs means forms. So polymorphism means many forms. Okay, let's take a real-time example. A woman. If the woman is sitting inside the home means her role is the mother. If that woman goes to the bank means her role is the customer. Okay, if she goes to the hospital, her role is the patient. Okay, actually a single person, but her role is different in different places. Okay, this is the real-time example for polymorphism. Okay, polymorphism means many forms. Okay, there are two types of polymorphism. One is compile-time polymorphism and another one is runtime polymorphism. In this session, we will discuss about the compile-time polymorphism, that is method overloading. Okay, so what is method overloading? Method overloading allows different methods to have the same name. Okay, but different signatures. Different signatures means where the signature can differ by the number of input parameters or the data type of the input parameters or a mixture of both. Okay, so this is called the overloading concept. Okay, and method overloading is also known as the compile-time polymorphism, static polymorphism or early binding. Okay, and if we want to write the method like adding two numbers and adding three numbers, what we will do? We have to create two methods to perform the same operation, that is addition operation. Okay, but if we implement this method overloading concept means what happens? You can use the same name two methods, but you give the different number of arguments. So what is the advantage for this method overloading? Increases the readability of the program. Okay, so there is no need to create more methods for the same operation. Okay, so what you will do? You can implement the method overloading. So now let's see this example. Then only you will be clear. Here, this is the example program for the compile-time polymorphism. Here I have created the adder class. And inside this class I have created two methods. Here the name of the methods are same, but I have given different number of arguments. So this is called the method overloading. Actually, I want to add the numbers, but in this method I add only two number of arguments, but in this method I add three number of parameters. Okay, addition operation is the same, but arguments alone different. Okay, this is the one way. Okay, so if we want to implement the method overloading means we have to give the same method name, but we have to give the different number of arguments. Okay, here this method return the addition of A and B. Okay, these statements are used to print the A and B values on our console. Okay, here this method is used to add three number of parameters. This is only the difference. The name of the methods are the same, but here I have only two number of arguments. In this case, I have three number of arguments. Got it? And here I have created one more class. In this class only I have created the main method. So I have to give the file name as this class name only because this class only have the main method. So this is my file name. Test2poly1 is my file name. Okay. And I have created the object for the adder class. Okay. So here this object is created outside of this class. Okay. So this class is outside of this class. Okay, and a new keyword is used to create the memory for this object at runtime, and this is the default constructor. Okay, and here this is the output statement. Here I have used the object to call the method which belongs to this object class. So what is it? This is the object of the adder class. This method belongs to the adder class only. Here I have passed only 2 number of arguments. So what the compiler will do, the control jumps from the 23rd line to here only, because in this method only I have the 2 arguments. The control comes here and printing the A value and printing the B value and adding A and B. That value will be returned using this return keyword, and the control jumps from the 7th line to here. Added value will be printed on our console. And here I have passed 3 values. So what happens? This is the object of the adder class. Okay, so I can access the add method which belongs to the adder class, because this is the object of adder class only. So the control jumps from the 24th line to here, because here only we have the 3 arguments. Okay, so this 11 will be stored inside the A, and 21 will be stored inside B, and 17 will be stored inside C. Okay, and I print all the values on our console with the help of the println method, and addition of 3 numbers will be returned. So the control jumps from the 14th line to 25th line and print the addition of these 3 values. Okay, let me execute this one. Here A value is 12, B value is 11. Okay, and this is the result for this statement. Adding these 2 numbers, 12 plus 11, 23. Okay, and A value is 11, B value is 21, and the C value is 17. Okay, and this is the result for this statement. So 11 plus 21 plus 17, 49 is the result. Okay, so this is the example program for method overloading. Okay, in this example we have used the same method name. Okay, how the compiler will identify? With the help of the arguments only, the compiler identify which method will be invoked. Okay, if you pass 2 number of arguments, this method will be invoked. If you pass 3 number of arguments, this method will be invoked. Okay, so this is the compile-time polymorphism. And see the one more example. Here test poly4, this is my class name, and inside this class I have created 2 methods, add and add. The method name is same. Okay, and here we have 2 number of arguments. Here also we have the 2 number of arguments. Then how the compiler will identify which method will be invoked if we call this method means with the help of the data type of the arguments. Both the arguments are integer, but here we have integer type argument and float type argument. So the compiler identify which method will be invoked when we call the add method. Okay, so here this add method is used to adding A and B, but A integer data type, B is also integer data type. Okay, and here also we have the same number of arguments, but A is integer, B is float. If I give here also int means what we will get? We got the compile time error. Okay, because that is invalid. Okay, so we have to give the different. If we want to give the same means what you will do? You have to give the different number of arguments. Here we have only 2 number of arguments. Here we have the 3 number of arguments. So you can use the integer data type. But in this case, I have 2 number of arguments for both add method. How the compiler will identify? With the help of the data type of the variable only, the compiler will identify. Okay, if we have give the same number of arguments means you have to give the different data types. Then only the compiler identify which method will be invoked. Got it? So here what happens, A plus B. So A data type is integer and B data type is float. So the result will be float only, but I want to convert that float value into integer. Okay, so I just use the typecasting method here. Okay, and the float value will be converted into integer. That value only will be returned because here I have given the return type as integer. Okay, if I am not use this typecasting here means I will get the error only, because here I have given int. Okay, the return type must be the int only. So it returns only the float, because here A is integer and B is float. So the addition of two numbers will give the float only. So we have to convert the float into the integer, because here we have the integer return type. That's why I have to convert the float into integer. Okay, and here I have created the main method. I have created the object for this testpoly4. This is my class name, and this is the default constructor, new keyword. You know very well about this one. And here, with the help of this object, I can call the add method. Its data type is integers only. Here, this is integer and this is the float. We have to append F letter for the float value. Okay, then only the compiler will understand this is the float value. Okay, and after encounter this line, what happens? The control jumps from the 18th line to the 3rd line. So this 5 will be stored inside the A variable and the 9 will be stored inside the B variable. After the execution of this statement, the addition of 5 and 9 will be returned from 7th line to the 18th line. That value will be printed on our console. Got it? And here T1 dot add of one int value, one float value. So the compiler identifies which method will be invoked. So the control jumps from the 19th line to 9th only. Actually here and here we have the same method names and the number of arguments also the same. But how the compiler will identify? With the help of the data type of the arguments only, the compiler will identify which method will be invoked. Okay, so this 11 will be stored inside this A variable and 22 will be stored inside the B variable. Okay, after the addition of these numbers will be returned with the help of this return keyword. The control jumps from the 13th line to the 19th line. What is the result? 33 will be printed on our console. Okay, let me execute this one. Here A value is 5, B value is 9. So this method is invoked. So what is the result? 14. And here 11 is the integer and 22 is the float. So this method is invoked. What is the result? 11 plus 22, 33 is printed. Got it? So polymorphism means many forms. Okay, here we have the single operation but different number of methods. Okay, but the method name is same. In this example, the number of arguments are different, but in this example, the number of arguments are same, the method name also same, but what is the difference? The data type of the variables are different. Okay, so what is the advantage of this type of polymorphism? It increases the readability of the program. So there is no need to give different names for these two methods. We can give the same method names. Got it? In this session, we will discuss about the method overriding concept in polymorphism. Now we will discuss the runtime polymorphism, that is method overriding concept. Here I have created two classes. Vehicle is my parent class and bike is my child class. Okay, so we already know about the inheritance. Here I have implemented the single type inheritance. bike is the child class and vehicle is the parent class. Bike inherits all the properties and behaviors from the vehicle. Okay, in between the parent and the child class, we have used the extends keyword. Okay, this means this is the single type inheritance. Okay, when a method in a subclass has the same name and the same number of parameters and the same return type as a method in its parent class, then the method in the subclass is said to override the method in the superclass. So this is the example program for runtime polymorphism. Method overloading is the compile-time polymorphism. Okay, so inside the subclass, that is the child class, we have the run method. Okay, inside the parent class, we have the run method. Here inside the round brackets, there is no parameters. Here also there is no parameters. And here the return type is void, and here also the return type is void. So if we want to implement the method overriding in our program or project, means what are the rules we have to follow? The names of the methods inside the subclass and superclass should be same, and the number of parameters inside the superclass and subclass methods should be same, and the return type of the methods inside the sub and superclass should be same. Okay, so we have to follow these rules, then only we can implement the method overriding concept. Okay, that is the runtime polymorphism. Okay, so here I have created the main method inside the subclass bike. So we have to give the file name as bike, and here I have created the object for bike, that is the child class. And here I have used the new keyword. New keyword is used to create the memory for this object during the execution of the program, and this is the default constructor. And I have created one more object for the parent class also, but it refers the child class. Okay, so now I call the method using the child class object. So what happens? After encounter this line, the control jumps from the 20th line to the 10th line. Actually, inside this bike we have the run method, and inside the vehicle also we have run method. Both the names are same, number of parameters are same. Here there is no parameter, and the return type is also same. The child class run only will be invoked. This method override this method which is present inside the vehicle, that is the parent class. Okay, so this is called the method overriding. Statement only will be printed on our console. Okay, and object1.run. Actually here I have created the object for vehicle. Okay, but it refers the child class only. Okay, so what happens? This run only will be executed. This run will not be executed. Okay, because here I have created the object for vehicle, but it refers the child class only. So if I call the run for this object, again the control jumps from the 21 to 12 only. So this statement only will be executed on our console. Let me execute this one. So this is for this statement, and this is for this statement. Now I want to call the parent class. Means what I will do? I have to create the object for vehicle class only. Then only I can call the method run which is present inside the vehicle. Let me execute the same again. Here vehicle is running. This is from this run method. Okay, if we implement the method overriding concept, means the method which is present inside the child class override the method which is present in the parent class. Okay, that's why we got bike is running safely for this statement, because this one is the object of bike, that is the child class only. Okay, if I call the run method, means the child class method only will be executed. The parent class run is overridden. Got it? So we have completed the polymorphism types. Runtime polymorphism, compile-time polymorphism. Compile-time polymorphism is the method overloading concept, and runtime polymorphism is the method overriding concept. Okay, I hope you all understand. We have completed this session. If you have any doubts, drop the message on the comment section. If this video is useful to you, like and share. For more videos, subscribe my channel, hit the bell icon, then only you will get the notification for my new updates. Have a nice day. Thank you.